Hello, my name is Jason Samuel,
I'm William Morrison.
My name is Alex Casale.
and we have created the Rubber Band Project together. And I introduced the project, started a trial run. First, we had figured out how to put the Rubber Band Project together as a group, and that going on in the project. The second thing we did was we had to step up and test the area and see where things was going with the measurements, and we raced our car. And lastly, we had started doing the figurations of PE and KE in rubber band cars. Then the Rubber Band Project, we chose this particular car because this was the fastest car. We could have chose Alex Rubber Band car. We chose Alex being the most consistent. Alex Rubber Band car was the consistent in providing the data in the trials. Alex Rubber Band car was the least of the group to weigh at least 0.741 ounces. So that was the one we chose because it was the best one to choose. The Rubber Band car design deformation, the length was 0.4375 feet with 5.25 inches. The width was 0.4792 feet, 5.7 inches. The axle denominator was 0.1 inches. Circumference of the wheel of the axle was 0.6912 inches. The weight was 0.4 slang, 0.741 ounces. The materials and tools we used the rubber band. We used measuring tape. We used a stopwatch, the camera. We used a weigh scale, and we used also XL. Beginning of the trial runs, first we set up our test trial area. Second, we set up the recording and instruments that we was going to use to do the trial run. The third, we recorded the data and used it in XL, and we found the calculations that we needed for the energy in the rubber band car for we can do the trial runs. We needed to do the measuring tape and directions for the car trail, so we needed to do the stopwatch measure it at the time, so we did that. And we recorded the run.
All right. So now, since we have to do the Excel calculations, first we must fill in the Excel sheet with the data we got. So we measured the distance and the time for our project. Second, we had to find the average velocity for each trial run. So by doing that, we had to divide distance. We had to divide distance by time. So D/T. And then for the third one, here we are. Give me 1 second. For the third one, we had to use a formula for the kinetic energy to find it. So in order to do that, we have to, give me 1 second. We had to do K E equals, we had to know the formula first. So write out the formula. So 1, 2, MB squared. So what is KE equals 1 over 2 times M times V squared? Well, M stands for the mass, the total mass of the vehicle. So the total mass of the vehicle was, so give me 1 second. K equals, here's the formula. So 1 over 2. So for M stands for mass. So in order to do that, you had to go like that, parentheses 0.0 0.014. Then and then after that you had to put the feet, the total distance. So in order to do the distance, you had to do 6. You have to put the distance in the fraction. So let me see, 6 over 10, 12 equals 2. Then after that, after you put the distance, you had to divide it by the seconds, how many times it took to get there. So 1.333, and then and then it gives you do the formula and you get the answer right here. So let me clear my thing real quick. Where did I clear at? Clear. So that's how you do it. So for the fourth one, we must convert the kinetic energy into joules. So in order to do that, so 1 joule equals 1.3552. So 1 joule equals 1 foot. 1 foot pound force. So you take that and you times the kinetic energy. So you basically had to convert kinetic energy into joules. So in order to do that, we must do that. And then, so how do you do on Excel? You do it like this. So F1 times E6. And then you get the answer. You do the answer. And then on the next slide, for the fifth one, we must plug in how many times we wind up the rubber band car back axle. So for the back, so how we did it, so we only did the back axle. We only did the back axle when we wind it up. So, and then 6, we find K. So how do you find K? Give me a second. So you had to do this. So for K, you had to K equals MB square. You gotta go like that. And then you gotta go NC squared. So you're wondering, what does this mean? So what it means that you got to times the mass by you gotta times the mass by v, and then you gotta square it, and then n is the n is the number of times you wind up the axle, and then C stands for the kinetic energy, I believe. Yeah, kinetic stands for kinetic energy, and then parentheses square, and then you get your answer. So how do you do it on Excel? You do M. You don't have to do the same thing as M, but you have to do D4 times D6 squared, and then you do it like this. Then you go 5. So go 5 times, and then D2 squared, and then you do the answers and you get your answer. So after you do that, give me 1 second. So after you do that, lastly we had to take K and find the max, minimum, and average. So how do you do that? So you go on Excel, you go equal for max, you have to do max. So max, and then you do like that. Then you do H6, H15 for the max. Then for the minimum, you have to do equals, and then parentheses, then H16, H6, 15. Then for the average, you do equal average. Sorry, I'm losing all the space I can get. Here, let me clear this out real quick. So for the average, you go this one equals H6, H15, and then that's how you find the average. Go ahead.
All right, so some of the advantage of the rubber band car, the reason why we chose Alex, as Jason said before, it was the lightest in the group, and compared to some of the other cars that we had in our group, his was the most consistent, and it was able to go past 5 feet almost every time that we used it, so we thought that would just be the best option. It's a simple design, made it simple and slim design, made it easy for it to go through the wind and cut through it and just get to the 5 feet consistently. On the bottle caps, there was glued rubber bands on it to give it traction when it goes across the floor, which helped very much. More advantages of it is that when we would wind up the rubber band car, the back axle too much, it would tend to like spin out or do like a little wheelie as it would go, so it wouldn't be as consistent and sometimes not even make it to the 5 feet. Without having, if you didn't like glue the rubber bands onto one of the bottle caps, sometimes after usage of it, the rubber bands will slide off of the bottle cap and it will lose the traction and make it slide around. So in the conclusion, our takeaways from it is that Alex's car was the lightest and best car for us to use for it, and that the rubber bands provide good traction for the cars, and Alex's car was consistent, providing data throughout the experiment, and that is the conclusion for it. Thank you, guys.